Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about question number 12 of JEE Advanced 2020. Here in this problem, we have 4 cases and we are going to find which one is or are true. As you can see here, we have x cosine of x sine of x squared cosine of x, and x squared sine of x. And we need to use an inequality that is going to have this. I'm going to start with using Taylor series for sine and cosine. Remember, sine of x can be written as x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial minus x to the power of 7 over 7 factorial, and so on and so forth. On the other hand, cosine of x can be written as 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the power of 6 over 6 factorial, and so on and so forth. So we are going to use these two. What you are seeing here is basically x cosine of x sine of x, and x squared cosine of x and x squared sine of x. So I need to convert whatever I have to x times that, or x squared times of that. Now let's focus on the first case, case number 8. In that case, we are interested in x cosine of x. To do that, I'm going to start with using the second case that I wrote and convert it to an inequality. Let's start with that. So since cosine of x is going to be 1 minus x squared over 2 factorial plus some other terms, first of all, I'm going to say that cosine of x is going to be greater than or equal to 1 over x to the power of 2 over 2 factorial. The reason is this term here is going to be a positive term. So because of that, cosine of x is going to be greater than what we have on the right hand side of this inequality. Now let's multiply both sides by x. So I have x times cosine of x is going to be greater than or equal to x minus x to the power of 3 over 2 factorial. And obviously now I need to take the integral of it. So to do that, I'm going to start to use the integral. And the integral that we have is going to be between 0 and 1. So I can say that the integral is going to be greater than the integral of x minus x cubed over 2 factorial from 0 to 1. And obviously we need to have this dx on both sides. So this integral is easy to calculate. X dx is going to be x squared over 2, and integral of x cubed over 2 factorial is going to be x to the power of 4 over 8, and we need to put this negative here. Everything is going to be between 0 and 1, and if we do calculate this, we are going to see that we are going to have 1 over 2 minus 1 over 8 minus 0, which is going to be 3 over 8. So what we can say is this side is going to be greater than or equal to 3 over 8, which is something that we already have here. So case A is correct. Now we are going to use B. We have x sine of x here, and remember, sine of x can be written as x minus x to the power of 3 over 3 factorial plus x to the power of 5 over 5 factorial, and so on and so forth. So if we multiply both sides by x, we can say that x sine of x is going to be x squared minus x to the power of 4 over 3 factorial plus x to the power of 6 over 5 factorial, and so on and so forth. Remember what we did for the previous case. We are going to use the same approach and say that x sine of x is going to be greater than or equal to x squared minus x to the power of 4 over 3 factorial. Now here we are going to take the integral from 0 and 1 from both sides, and if we do this, then we can simplify things and write it as x to the power of 3 over 3 minus x to the power of 5 over 30, and this is going to be between 0 and 1. So to calculate this, we have 1 over 3 minus 1 over 30, which is going to be 10 minus 1 over 30, or 9 over 30. Now let's focus on case C. For case C, we are going to use x squared times cosine of x. And remember, we had cosine of x as 1 minus x to the power of 2 over 2 factorial plus x to the power of 4 over 5 factorial, and so on and so forth. And if we multiply both sides by x squared, and then we can write it as x squared times cosine of x is going to be greater than or equal to x squared minus x to the power of 4 over 2 factorial. And then if we take the integral of both sides, similar to what we had before, we can write it as x to the power of 3 over 3 minus x to the power of 5 over 10 from 0 to 1, which is going to be 1 over 3 minus 1 over 10, which is going to be 10 minus 3 here and 7 over 10. So this one is not correct. Now let's focus on the last one. For the last one, we can write that x squared sine of x is basically greater than or equal to x to the power of 3 minus x to the power of 5 over 6. This is based on Taylor series that we saw before. Now if we take the integral of both sides from 0 to 1, you can see that this is going to be x to the power of 4 over 4 minus x to the power of 6 over 36 from 0 to 1, which is going to be 1 over 4 minus 1 over 36, which is basically 8 over 36. We can write it as 2 over 9. So the last case is also correct.